Alright, in this video let me illustrate the most important equation in the consumer theory, that is a Slotsky equation. So previously we talked about two major problems about the consumption behavior, utility maximization problem and the expenditure minimization problem. From the former UMP, we derived Walrasian demand and indirect utility, and from the second problem EMP, we derived the Hicksian demand and expenditure function. Okay, and in the previous video we discussed the relationship between these two demand functions and the relationship between the two value functions, the so-called duality. Okay, so by the duality between the two demand functions, it turns out that Hicksian demand can be expressed as the Walrasian demand. Okay, so given Hicksian demand H can be expressed as the Walrasian demand. So if we substitute expenditure function in place of W, in place of a consumer's income, like this, and we obtain the Hicksian demand. Okay, so which means with the information about expenditure function and with the information about Walrasian demand, we can recover Hicksian demand. And there is a converse relationship, reverse relationship. Walrasian demand can be expressed as a Hicksian demand. Yeah? If we substitute consumers of indirect utility in place of the target utility, so function V, yeah, in place of target utility, then we obtain Walrasian demand. Okay? So that was the duality between Hicksian and Walrasian demand. Okay? And the similar relation holds between these two value functions. Okay? So we saw the inverse relationship between expenditure and indirect utility. So the duality makes a link between these two. Okay? So there is a duality between two demand functions and also duality between these two value functions. Okay? And the link between Walrasian demand and indirect utility is created by Roy's identity. So Roy's identity enables us to find out Walrasian demand from the indirect utility function. Right? So with this link is given by Roy's identity, and the link between Hicksian demand and expenditure function is given by the Shepard lemma. So the lemma helps us recover Hicksian demand from the expenditure function. So by the Shepard lemma, if we take the derivative of expenditure function with respect to price, we can obtain Hicksian demand. Okay, so the final link is created by Shepard lemma. Right. So with the duality and Roy's identity and Shepard lemma, we have complete connection among these four components. Okay, so they are interrelated to each other, as is displayed by this figure. Yeah. So that is a kind of the essence of classic consumer theory. Coming from this duality. Okay? Duality between UMP and EMP creates the link between the link between the two demand functions and the link between the two value functions, and two mathematical lemmas, Roy's identity and Shepard lemma, creates the link between these two components. Okay. Alright, so in this video what we are going to do, we are going to study one more thing coming from the duality. So this time, this result, so the previous result is more concerned about the relationship between these two demand functions at some specific point. Yeah? And the second result from duality, the so-called Slotsky equation, is now concerned about the responsiveness of these two demand functions with respect to change in price. Okay, so now we compare these two. We compare the responsiveness of demand, each demand function, in response to change in price. Okay, that is presumably the most important question in classic consumer theory, because now we examine how does people demand respond to change in demand or change in the price. Okay, is usually referred to as the price effect or total effect. So the change in demand for each commodity due to change in price. Okay? And by this Slotsky equation, it turns out that this total effect can be decomposed into substitution and income effect. So I guess when you took the intermediate level of microeconomics, you've already seen this formula, decomposition formula. So the total price effect can be expressed as a sum of the two different effects, substitution and income effects. Okay, so in this video, I'd like to pay attention to so rather the formula itself, I'd like to pay attention to implication of this equation. So why do we have to consider this equation as the most important one in classic consumer theory? Okay, so I'm going to talk about the two important implications of Slotsky equation, and secondly, I'd like to pay attention to how to derive this equation from the duality. Okay. All right. So the exact statement of Slotsky equation is given by theorem 1.12. So we assume that preference relation satisfies the preference relation satisfies the 5 assumptions. So in addition to 3 basic assumptions on preference relations, we are going to assume local non-satiation that is necessary for Waller's law. Okay, so P dot X is equal to W. Okay, so when we establish the duality between X and H and V and E, we made use of monotonous assumption, but it turns out that can be generalized to can be weakened to local non-satiation. So with just the local non-satiation, we are able to establish the duality between Hicksian demand and Walrasian demand, and the duality between these two value functions. Okay? And by the way, the law of this local non-satiation is, under this assumption, we know that P dot X is equal to W. So the consumer's wealth is totally exhausted for consumption if X is optimally chosen. Okay, and then one more assumption on preference relation is strictly convexity. Okay, the law of this assumption is so this assumption is necessary for differentiability of demand function. Okay, so in the derivative version of the Slotsky equation, we use the derivative of the Walrasian demand and Hicksian demand with respect to price. Okay, but for differentiability of demand function, strict convexity is essential. Okay, that is not sufficient. So although preference relation is sufficiently strictly convex, we can guarantee that these two demand functions are differentiable. But at least this assumption is necessary. All right, and then the equation states that for every pair of price factor P and consumer's wealth W and the target utility U, but this target utility is given by the indirect utility. So the highest level of utility obtainable given these two parameters. Okay? And we have the followings. The total price effect on demand for good L. So we take the Walrasian demand for good L here and take the derivative with respect to P sub K, so the price of good K. So we consider a situation where price of good K changes, whether it changes marginally, so it marginally increases or decreases. Okay, and the effect on the demand for good L can be decomposed into substitution effect, and this is measured by the derivative of Hicksian demand with respect to the same price. Okay? And the income effect. And income effect turns out that so it can be expressed as the product of these two. Okay? So let me first remind you of the the meaning of each effect. So what is the so what do we mean by substitution and income effect? Okay, and briefly, and illustrate how to derive this equation from the duality. okay, and so on. Okay, so let me start with the substitution effect. So the definition of the substitution effect appears on page number 55. So the effect measures the change in demand due to change in the relative price. Okay, so holding the consumer's purchasing power fixed. All right, so the way to understand this definition is, so the best way to understand this definition, so the substitution effect, is to, so let me work with a two commodity space. So suppose that there are two goods, good one, and good two. And then basic constraint can be written as P1x1 plus P2x2 is smaller than or equal to W. Okay, now we consider price change in good one. So P1 changes to P1 prime. Then the new Gaussian line can be written as P1 prime x1, P2 times x2 is less than or equal to W. Yeah, so at first glance, if P1 changes, just one component changes in the basic constraint. But if we divide this inequality by P1 prime, x1, P2, P1 prime, x2, less than or equal to W over P1 prime. Now it is very self-evident that two things change. Okay, two things indeed change. So change in price of a good one brings about change in the relative price. Yeah. So if P1 increases, then means good one becomes more expensive relative to good two. In other words, good two becomes more cheaper relative to good one. Okay. So if good one is relatively more expensive, we can anticipate some transition from good one to good two. People tend to demand more for good two, right? So there is a change in the relative price. At the same time, W over P1 also changes. So this is often interpreted as the consumer's relative income. So relative income in terms of good one. Okay. So this quantity measures. This quantity is concerned about the consumer's purchasing power. Okay. And if the price of a good one changes, this relative purchasing power also changes. Okay. So two things change, but the substitution effect isolates the effect on the demand for each commodity. So change in the demand for each commodity due to change in the relative price only. Okay, meaning that we maintain the purchasing power fixed. Okay, and isolate the change in demand for each commodity due to change in this relative price. Okay, then now we have to think about, so with this definition in hand, now we have to think about how to adjust consumers' purchasing power. So how to maintain the consumer's power fixed. And there are two ways, Hicksian compensation and Slotsky compensation. Okay, and then in the first compensation, we adjust the consumer's income to the extent that we give the consumer just enough money to get back to the old indifference curve. Okay, so to explain the Hicksian compensation, let me use this figure. All right, so here the gray line indicates the Gaussian line before the price changes. Yeah, so let me say the original price factor is given by P. Okay, and the new price factor is denoted by P prime. Okay, so under this original Gaussian line, at the bundle A, the Gaussian line is tangent to the indifference curve. Okay, so we can think of a bundle A as the optimal choice. So the x and y coordinate of bundle A indicate the Walrasian demand for good 1 and good 2, x1 star and x2 star. Yeah, so the bundle A indicates the Walrasian demand given price vector P and the consumer's wealth W. Okay, and the level of this indifference curve, so the level U stands for the indirect utility. Okay, so the highest level of utility attainable given this given this price vector P and consumer's wealth W. So U is V of P comma W. Okay, so with this notion, we can express this Walrasian demand as a Hicksian demand. So by duality between Hicksian demand and Walrasian demand, we know that this is equal to Hicksian demand when target utility is given by this highest level of utility. Okay? So what does it mean? In order to attain this level of utility, given price vector P, and the consumer wants to minimize expenditure, yeah, then the optimal choice, the way of minimizing expenditure given this environment, is to choose bundle A, is to choose the same bundle. Okay. All right, so that is bundle A. And now we imagine price changes. So we can consider two possible cases at the same time. So the price of a good 2 falls, or the price of a good 1 increases. Yeah? In either case, if P1 increases, then bottom line will shift inward like this, so toward the origin. Yeah? But if P2 falls, bottom line will fan out, so will shift out like this. Yeah. So in either case, the slope of the new bottom line is given by, so is identical with the slope of this purple line. Okay, and that is indicated by P prime. Okay, so now we discuss how to maintain the consumer's purchasing power fixed. Okay, it means, so in case of this case, in this case, when the price of a good 1 increases, okay, then bottom line will shift in like this. Okay, but we adjust consumer's income, so we give the money to the consumer, just enough money so that now the consumer can reach the previous indifference curve. Okay, but with this new slope, the consumer chooses not bundle A, but rather bundle B. Okay, so if we increase consumer's income to the extent that, with this new slope, we adjust the income to the extent that the new bottom line is now tangent to the original indifference curve. Okay, but this new bottom line is not necessarily tangent to the previous indifference curve at the same point. So in this case, it's tangent at point B, at the new bundle. So bundle B can be thought of as the solution to expenditure minimization problem under new price vector P prime and the target utility U. Okay, so point B is going to be Hicksian demand under new price vector P prime and target utility U. Okay, so we adjust the income this way in case of Hicksian compensation. Okay, so in this case, the substitution effect on the demand for good 1 is given by this difference between the two Hicksian demand. So the x coordinate of point A, that is a Hicksian demand for good 1, okay, and the coordinate of x coordinate of point B, that is a Hicksian demand for good 1 under new price vector. Okay, and if we consider marginal change, okay, so marginal change in P2, And the substitution effect on the demand for good 1 can be written this way. Derivative of the Hicksian demand for good 1 with respect to P2. Okay? So that indicates the change in demand due to change in the relative price. Okay? So we use the slope of the new version line, okay? But we adjust the income to the extent that the consumer could go back to the old indifference curve. All right, that is a Hicksian compensation. But there is another way of adjusting purchasing power. There's a Slotsky compensation. Okay, so if we attempt to adjust purchasing power by way of Slotsky compensation, then we give the consumer just enough money to get back to the old consumption bundle. Okay, so the main difference between these two compensation methods is illustrated by this figure. And so here, the old version line is this given by this black one, this solid line, okay? And now we consider price change. So P1 increases. So demand, the version line will shift inward toward the origin like this. Yeah. All right. So, okay. So in case of a Hicksian compensation. Okay, and then this point is the optimal choice. Yeah, when before the price changes. Okay, before the price changes. Okay, and the level of this indifference curve indicates the highest level of utility. All right. So in case of a Hicksian compensation, as we just saw, we adjust consumers' income to the extent that the new version line is tangent to the original indifference curve. Okay, so the substitution effect on good 1 is described by this difference. Okay, in case of a Hicksian compensation, but in case of a Slotsky compensation, we give the consumer just enough money to get back to the old consumption bundle. Okay, so we adjust consumers' income. So, but by the way, in case of a Hicksian compensation, we need to give money to the consumer as much as the length of this interval, more precisely, the length of this interval times P2. Okay. So delta times P2, that is the necessary adjustment in income in case of Hicksian compensation. But in case of Slotsky compensation, we adjust the income as much as, so now the consumer can afford the previous optimal bundle. Okay? So we adjust consumer's income further. So the new version line is now passing through the original bundle. Okay. So in this case, the new version or the previous optimal bundle is on the version line. That means it is now affordable. Okay. So so we maintain the consumer's purchasing power this way in case of Slotsky compensation. So in this case, the consumer will choose different point, okay, rather than the previous one. And the substitution effect due to Slotsky compensation is given by this difference. Okay, so the substitution effect on demand for good 1 due to change in the relative price in case of Slotsky compensation is given by this difference. Okay. All right, so as you can see in this figure, two compensation methods make some difference. Yeah? In case of discrete change, so if P1 changes a lot, so it shifts the margin line inward as much as this, and there is some gap between Hicksian and Slotsky compensation. But if we consider marginal change, yeah, so if the margin line changes slightly, then there is essentially no difference between Slotsky and Hicksian compensation. Okay? And it turns out that there is a no change even for a discrete change if the indifference curve is strictly convex toward the origin. Okay, so this is described in the next slide using the CS function. Okay, so remember the key parameter of the CS function is the parameter R that is related to elasticity of substitution. So the degree of substitution between these two goods is denoted by sigma, and the sigma is related to the key parameter of the CS function. Okay? More precisely, that is 1 over 1 minus R. So here the parameter R takes a value between negative infinity and 1. Okay? So if R approaches 1, then the sigma approaches infinity. Yeah? That describes the case of perfect substitutes. So if R equals 1, you can easily see that this utility function boils down to a linear function. Yeah? So indifference curve is a linear like this. So describing perfect substitutes. And at the same time as R approaches 1, then the elasticity of substitution approaches infinity. So meaning that two goods are perfectly substitutable. The elasticity converges to infinity. Yeah? Okay. And then the other extreme case is a perfect complement. So when R approaches negative infinity and sigma approaches 0, so the degree of substitution is almost 0. So two goods are not substitutable. Okay, so yes, so it can be shown that as R approaches negative infinity, this CS function approaches the Leontief preferences. Okay, so the indifference curve has an L shape like this. But in case of a perfect complements, there is a no difference between Slotsky and Hicksian compensation, meaning that if the indifference curve is sufficiently convex toward the origin like this, okay, the sufficiently convex means the curvature of the indifference curve is very high, like this. Okay, so the L-shaped indifference curve describes the extreme case. So in that case, we can easily see there's a no difference between Hicksian and Slotsky compensation, because think about this situation. So the original bottom line is given by this one. Okay, and then we consider increase in price of a good one. Okay, so the black solid line indicates the final bottom line. All right, and then the previous optimal bundle was given by this one. Okay, and then if the price of a good one decreases, so the bottom line becomes a flatter like this. Okay, but so how to adjust the income in case of substitution effect when we compensate the consumer by way of Hicksian compensation? Okay, so we adjust the income with this new slope, okay, to the extent that it is exactly tangent to the old indifference curve. Okay, and we're gonna make the same at the same optimal choice as before. So essentially there is a wait a second. Yeah, so yeah, we need to adjust the income as much as this in case of Hicksian compensation, right? But in case of Slotsky compensation, we adjust the income to the extent that the new bottom line is passing through the original consumption bundle. Okay, so we have to adjust the income in the same way. So there's a no difference between the Hicksian and compensation, or Hicksian and Slotsky compensation. Okay, and one more remarkable thing, you can easily see that in this figure. In case of perfect complements, there is a no substitution effect, right? So there is a no change in demand due to the change in the relative price So the total effect is wholly captured by income effect. Yeah, that is quite intuitive, because in case of perfect complements, even though good one it becomes relatively cheaper or relatively expensive, we can expect some transition from good two to good one, or the other way around. Right? So there's no substitution effect. But in other extreme case, so in case of perfect substitutes, okay, so now the indifference curve is not sufficiently convex toward the origin, and in case of a discrete change, we have a large gap between Hicksian and Slotsky compensation. So depending on the way of adjusting income, the amount of compensation necessary makes a huge difference. Right? So in case of perfect substitutes, suppose that this is the original optimal choice, okay, under this original budget line. Yeah? All right, and then we consider price changes. Okay, the same situation as before. So we consider the situation price of a good one decreases. Okay? So the final budget line will shift out as indicated by this solid black line. Okay. All right. So this is a final choice. All right. So if we consider Slotsky compensation in this situation, yeah, so we don't have to compensate any money for the consumer in case of Slotsky compensation. This is the original budget line, and the final budget line is already passes through this optimal bundle. Okay, so even after price changes, the previous optimal choice is the previous optimal bundle is affordable. Okay, because in the previous case, before the price changes, the optimal choice indicates that consumer consumes only good two. Okay, so even though the good one becomes more cheaper. Okay, so if there is no change in the price of a good two, the optimal previous optimal bundle is still affordable. Okay, so in case of a Slotsky compensation, we don't have to compensate anything. But in case of a Hicksian compensation, okay, so with this new slope, so from the origin, we gradually increase the consumer's income. So we adjust. So this can be thought of as the adjustment process of income, to the extent that now we can reach the original indifference curve. Okay, so as much as this. So we need to adjust the income as much as this. Yeah, as much as the length of this interval. Because the new budget line, so the budget line with the new slope will reach the previous indifference curve at this point. Okay, that means in case of Hicksian compensation, we need to adjust income as much as this. Okay? So there is some gap between Slotsky and Hicksian compensation if the indifference curve is not sufficiently convex toward the origin, and plus when we consider discrete price change. Okay? All right. Okay, so after considering substitution effect, the remaining part in the total price effect is called the income effect. Okay, so the income effect can be thought of as, so when price changes, the consumer's purchasing power also changes. So we can anticipate some change in demand for commodities due to this increased or decreased purchasing power. Okay, so if P2 force, this was the gray dotted line, dashed line, was the original budget line. But if P2 force, that improves the consumer's purchasing power. Okay, so after considering substitution effect, the budget line will shift upward vertically as much as this, capturing the improved purchasing power. Okay, so that is called the income effect. Okay, so in this figure, income effect is measured by, so the way of quantifying the income effect is, so that is measured by the change from B to C. So after considering substitution effect, so we consider change in demand due to change in the relative price, and the remaining part, okay, the other part is captured by income effect. Okay, so the change in demand for good 1 from B to C visualizes the income effect. Yeah. All right, then let me illustrate how to derive Slotsky from the duality. Okay, so we did one price vector P and the consumer's wealth W. As I told you, U stands for the highest level of utility. Okay? And by the duality, we know that if U is given by indirect utility under same parameters, under same parameters, and we have this relationship. Okay, so this is due to the relationship between the indirect utility and expenditure function. So we know that indirect utility becomes the inverse function of expenditure function with respect to the target utility. So the original expenditure function is this. Yeah. But if we substitute indirect utility in place of U, okay, that it spits out the consumer's income W. Okay, because here U is given by indirect utility, we have this relationship. Okay, due to the duality between expenditure and indirect utility function. And furthermore, due to duality between Hicksian demand and Walrasian demand, we know that Hicksian demand for good L can be written as Walrasian demand for good L even P and expenditure function E of P comma U. Alright, so now what I'm gonna do, I'm gonna take the second identity, so this identity, to differentiate with respect to price of a good K. Okay, so we consider marginal change in the price of a good K and examining the responsiveness of these two demand functions. Okay. So the left-hand side, we obtain the partial derivative of a Hicksian demand for good L with respect to pk. Okay? But on the right-hand side, now we have to consider derivative of this with respect to p sub k. But p sub k appears here in place of the price vector and also appears in place of w. So we have to consider the total derivative. Okay, so we first take the partial derivative of xl, so Walrasian demand for good L with respect to p sub k. Okay, and then we know that E of P comma U, expanded function, is equal to W when U is given by target utility. Okay, so instead of E, let me substitute W. Okay, and then once again, P appears in this place, so we take the derivative with respect to W. Okay, and by the channel, we multiply by the derivative of the expenditure function with respect to P sub k. So P sub k. Okay. And then Shepard lemma tells us this guy is equal to Hicksian demand for good k. Okay. Oh, sorry. Hicksian demand for good k. P comma U. Alright, and then U is given by indirect utility. So we can substitute indirect utility V. And by duality between Hicksian demand and Walrasian demand, we know that this is a Walrasian demand for good k. Given price factor P and consumer's wealth W. Okay, so consequently, we obtain this. The total effect on the demand for good L due to change in the price of good K plus this quantity X sub K star, okay, is equal to so the responsiveness of a Hicksian demand for good L with respect to the same price change. Yeah? And moving this term to the left hand side, we obtain the Slotsky equation. Yeah? So the total effect this is a total effect can be decomposed into derivative of a Hicksian demand. This is a substitution effect. And this term. Yeah? And then together with this negative sign, we call this income effect. Income effect. Okay. So I guess it depends on the text view. Sometimes in some text view, income effect is defined as this the product of these two, so except this negative sign. But in some text view, income effect is defined as this. Yeah, I have to double check, but it does not matter. I mean, once again, the basic idea of Slotsky equation is the total effect is the can be decomposed into these two different effects. Okay, and then the way of proving this Slotsky equation is we made use of duality several times. Yeah, so we use the duality between Hicksian expenditure function and indirect utility, and the duality between the two demand functions. Yeah, so once we understand this duality, we can derive the Hicksian, we can derive the Slotsky equation in this way. Okay. All right. So what is an implication? Now let me discuss the implication of the Slotsky equation. So why do we have to consider the Slotsky equation the most important result in classic consumer theory? The first important implication is, if the Slotsky equation describes the relationship between the Walrasian demand and the Hicksian demand. But one benefit from working with Walrasian demand is the two parameters in the Walrasian demand are observable. Okay, so in the end, because we can observe the price factor and we can observe the consumer's wealth from the data, and we can observe the consumer's choice from the data. So every component is observable. Okay, so the observed consumer behavior, consumer's choice from the data, can be thought of as the Walrasian demand. Okay, so from the data, we can find the relationship between this observable data, P and W, and the observed choice. Okay, and that can be thought of as the Walrasian demand. So the relationship between the two, actually three observable economic data. Okay, but one disadvantage from working with this Hicksian demand is a target utility is not observable. Okay, so in contrast with Walrasian demand, Hicksian demand is not observable because we can't observe target utility. So although we can observe the consumer's choice in the market, we can't interpret that as a Hicksian demand, right? Then you may wonder, why do we have to consider Hicksian demand? Okay, Hicksian demand conveys much more, important information about the consumption behavior. So if we can make a guess about if we have information about this target utility, we can make a better prediction about the consumer's behavior, like a substitution effect. And furthermore, we can give a better estimate about the welfare change. Okay, if price changes, the consumer's well-being also changes. So consumer's welfare also changes. Okay, so the government has to compensate for that welfare change, just like this COVID situation. The government wants to subsidize the consumer, the people, the national people, and then we can make a better prediction, better estimate about the necessary subsidy in case of price changes, if we have information about this Hicksian demand. Okay, that's why we try to isolate. So we try to separate this substitution effect from the total effect. Okay, that is quite obvious from this figure. Okay, although price changes, the change in optimal choice from A to B does not affect the consumer's well-being. Okay, so although we can observe the consumer's choice from A to B, we can say that consumer's well-being does not change at all. Okay, so we don't have to compensate at all due to as analyst for this change in the optimal choice. Yeah, so that is a one benefit. That is a one important observation we can make from the analysis of Hicksian demand. Okay, from the analysis of Walrasian demand, we can't observe such a thing. Okay, because in case of Walrasian demand, if the Walrasian demand changes, okay, then people's well-being, people's welfare also changes, as is illustrated this figure. Although we can observe the change in the optimal choice from this point to this point, now the indifference curve may be different. Okay? So now the peoples get better off. Okay? After this Slotsky compensation, that means we compensate too much. Okay, too much than necessary. So Hicksian compensation, by the analysis of Hicksian demand, we can obtain the better estimate about the necessary compensation, just like a Hicksian compensation. Okay, and then the Slotskycation gives us the information about the Hicksian demand. Okay, so by comparing the responsiveness of the demand function in the Slotskycation, although Hicksian demand is not observable, its responsiveness to change in price can be computed from the observable Walrasian demand. Okay, so derivative of Hicksian demand can be written as derivative of Walrasian demand plus the income effect. Okay, minus income effect plus income effect does not matter. Okay, the other component. All right, so we have this one. Okay. So from this figure. Okay. From this figure. So if this guy. So we have this. So the responsiveness of Hicksian demand is going to be the sum of these two. Okay? So suppose that this guy is strictly positive, meaning that as consumers get wealthier and wealthier, the demand for good L increases. We call that normal good. Okay? So as income increases, if the demand for the good, it also increases. So the income and the demand move in the same direction. We call that good, the normal good. Okay? So if that is a positive, we can see that Hicksian demand is more responsive to change in price, just like this figure. Hicksian demand is a steeper. So it is steeper than the Walrasian demand. Am I right? Plus, negative. Okay, so usually this guy takes a negative value, and we add some positive value. Okay, it means now this guy is less responsive to change in price. Okay, so in such a case, because we put the price on the vertical axis in microeconomics, so Hicksian demand becomes steeper. Okay, so it is less elastic. So Hicksian demand is less elastic in response to change in price. Okay? In case of normal good. So if price changes from this PL to PL prime, okay, we decompose the total effect into two pieces. Yeah. So this one is a total effect. So the change in demand for good L due to these price changes. Okay. And then we can isolate the substitution effect from the Hicksian demand. So this change is a substitution effect. And the other change is captured by the income effect. Okay. So here income effect is a positive. I mean, because price of a good L decreases, right? So it means it improves the consumer's purchasing power. And due to this improved purchasing power, demand for good L further increases. It means this good is a normal good. Okay? And the next figure describes the situation of inferior good. Okay? So inferior good indicates the demand for that good and income now moving in the opposite direction. So in terms of the derivative, the sign of this derivative is now negative. Okay? So we have a negative value here, and then we subtract away another negative value from this effect, so that we can see that Hicksian demand is a more elastic in response to a change in price. Yeah? So that gives us more flatter Hicksian demand compared to the Walrasian demand. Okay, so in case of inferior good, we can see that Hicksian demand is a flatter than Walrasian demand. Okay, so if we consider price change from PL to PL prime, the total effect is right here. This is a total effect. Okay? And then substitution effect is bigger than total effect. This is a substitution effect. Okay? And then the income effect takes the opposite value. So this amount, okay. Yeah, this amount is given by the income effect. Okay, so if we isolate the substitution effect due to change this price, people tends to increase demand for good L as much as this. Okay, But even after considering improving purchasing power, because this is inferior good, so now people reduce the demand as much as this income effect. Okay, so total effect, the size of a total effect is smaller than the substitution effect. Okay, consequently, Walrasian demand becomes less, becomes inelastic compared to the Hicksian demand. All right, that is the first implication. And the second implication of the Slotsky equation is we can deduce the law of demand. Okay, the basic principle of the demand function. Okay, so when those demand functions, so demand for good L, have a negative association with change in price. Okay, in other words, demand for good L has a negative slope over its own price. So when is the demand function is decreasing over PL, as we have seen in the textbook. Okay? So from the Slotsky equation, from the previous proposition, in proposition 1.8, we studied proposition 1.8 was the where is it? Yeah, the Hicksian demand has negative semi-definite derivative matrix. Okay, so that means unless the substitution effect due to change on its own price, okay, so the diagonal entries take the negative value. Okay, how can you say that? Okay, so from the fact that Hicksian demand has a negative semi-definite derivative matrix, implies that substitution effect, this should be P sub L. Okay, so if we consider change in price of good L and consider substitution effect on demand for its own good in demand for good L, that is always negative. Okay, so the substitution, its own substitution effect is always negative. How can I say that? How can I say that? Because I think that can be best illustrated in case of two goods. So in case of two goods, we have demand for good 1 and demand for good 2. Okay, so this derivative matrix is going to be 2 by 2. So derivative of H1 with respect to P1, and the same demand with respect to P2, and derivative of H2 with respect to P1, and H2 with respect to P2. That is the derivative matrix of Hicksian demand with respect to P. Okay, because Hicksian demand has two components, demand for good 1 and good 2 in case of two commodities. So it has two price, okay, price of good 1 and price of good 2. So the derivative is going to be 2 by 2 matrix. And we know that this is a negative semi-definite. So this guy should not be bigger than 0. Okay, so it should be lower than or equal to 0. So the own substitution effect, so it's effect on price of a good, effect on demand for a good 1 due to change in price of a good 1. Yeah, that is always negative. Okay, and we also know that the determinant of this 2 by 2 is a positive. That is a consistent with negative semi-definiteness. Okay, so the first principal minor takes a negative value, and the second principal minor takes a positive value. If the sign alternates like this, we call the matrix negative semi-definite. Okay? And we know that this guy is a negative value. So if this is a positive, okay, so the substitution effect on demand for good 2 on its own price, so effect on the demand for good 2 due to the change in its own price, if that was a positive, then the sign of the determinant is no longer positive, because we know this is a negative number, and if this was a positive, okay, then the product of these two numbers gives us a negative number. Okay, and furthermore, in the determinant of this 2 by 2, so the determinant of this 2 by 2 is AD minus BC. Okay, but we can say BC is always positive because we know this is a symmetric matrix. Okay, so this guy is exactly identical with this guy. Okay, we verify this fact using the Shepard lemma. Because a Hicksian demand is a derivative of the expenditure function, so this is a cross-partial derivative, and this is also a cross-partial derivative, and the order of differentiation does not matter. So these two components are equal to each other. Okay, so the product of B and C is always positive. So we take away the positive number. So if D was a negative, or if D was a positive, we are gonna get the negative determinant. That is immediate contradiction with negative semi-definiteness, meaning that negative semi-definiteness implies all entries on the diagonal are negative. Okay, or negative. So proposition 1.8 states that, implies that substitution effect due to change in its own price is always negative. Yeah? So if we consider price effect on good L, when the price of a good L changes, then the associated substitution effect is always negative. Yeah? So what does it mean? What does it mean? We know substitution effect. So this guy is always negative. Okay, and by the Slotsky equation, we know that this is a total substitution effect is equal to total effect. Okay, so that is of our interest. So we want to see whether that is a positive value or negative value. Okay, and then plus the derivative of XL with respect to W times XL. All right. Yeah. So we have a negative value on the left-hand side. Okay, and imagine that this is a positive. It means if good L is a normal good, so this is a positive value, and in order to have a negative value, yeah, as the sum of these two, we can see that this guy should take a negative value. All right, so that gives us the law of demand. That states that if good L is a normal, so the demand for good L move in the same direction with a change in the income. In other words, the derivative is a positive. The Walrasian demand function for good L satisfies the low demand. Okay, so its demand curve. So demand for good L and its price have a negative association. Okay. All right. So in other words, so in case of normal good, angle curve or the wealth expansion curve look like this. Yeah? So if we shift up, so if we changes the bottom line vertically, with the same slope. This relative expansion curve collects the set of optimal bundles. And then we can see that as income rises, the people increase the demand for both goods. So we can see that from this positive slope, we can see that the two goods are normal. Okay. So in that case, the demand curve has a negative slope over its own price. Okay? So satisfying the law of demand. And then 4 ways of classifying the set of goods into different categories based on the responsiveness to price or income change. Okay, so we say if Walrasian demand for good L increases with income, then good L is normal. If Walrasian demand decreases, good L is inferior good. Yeah? And if the Walrasian demand increases with its own price, then we say good L is a given. Yeah? So if this guy has a negative derivative with respect to its own price, that is a regular good. If that is a positive sign, we say it is a given. And if the Walrasian demand increases with the price of the other good, okay, so if demand for good L increases with price of good K, okay, then we say good L is a gross substitute of good K. If it decreases, we say good L is a gross complement of good K. Yeah. So if PK increases, then if the demand for good L decreases, okay, so they move in the opposite direction. Okay, then we can see some complement relationship between good K and good L. But if they move in the same direction, so if the good K becomes more expensive, if we can anticipate some transition from good K to good L, that means there is some substitutability between good K and good L. Yeah? So in that case, we say good L becomes a gross substitute of good K. Okay, and finally, if the Hicksian demand for good L increases with P sub K, okay, then we say good L is a net substitute of good K. If the Hicksian demand for good L decreases with P sub K, we say good L becomes net complement of good K. Okay, so I guess you have seen this taxonomy, so the way of classifying goods into several types, depending on the sign of the derivative of the Walrasian demand with respect to income or price, and depending on the Hicksian demand, so the derivative of a Hicksian demand with respect to price. So here is just a summary of the classification of goods into several categories. And in the final lecture slide about the Slotsky, I put the summary picture that is from the textbook. So from the UMP, utility maximization problem, we obtain Walrasian demand and the indirect utility. And from the EMP, we obtain Hicksian demand and expenditure function. And by duality between the two demand functions and the duality between the two indirect utility functions, we have a connection between these two components for each pair. Okay, and Roy's identity gives a connection between these two, and Sheffard's lemma gives us a connection between these two. Okay, and then the law of the Slotsky, it allows us to compare the responsiveness of the demand functions, the two demand functions. Okay, so it gives us a connection between these two demand functions in terms of the derivatives. Yeah, so we can infer responsiveness of a Hicksian demand from the Slotsky, and the benefit of that, the benefit from working with a Hicksian demand, we can make a better prediction about the and better a better prediction about your consumer behavior, so we can make a better estimate about the welfare change. Okay? All right, so hope you enjoyed this video. I'm sorry about the length of this video. It exceeded 1 hour, but hopefully you find this video helpful. Okay?